And we are recording.
All right. Hello, welcome to our second presentation concerning the Quack Track. I'm Noah, and I'm here with Cole and Evangeline. So our project, just to remind everyone, the end goal is to have a toy duck that can use a camera to pick out a user and follow them around as they're walking around. Ideally, we can have multiple ducks, so you can have like a whole herd of ducks following you around. The minimum specs involve being able to follow a single user in an otherwise empty room. Hopefully, we can include things like obstacle detection and following a person when they're not the only person in the room. And maybe if we have enough time, we can look into recognizing gestures and giving additional commands for those. So part of this includes video streaming to a website and a control panel on the website so that you can control the duck through there and so that you can see what the duck is seeing. It's the device is pretty small and there's two wheels. The one of the wheels will turn faster when we want it to turn left or right. Currently, we have pretty much achieved our minimum specs. We have a car that is not shaped like a duck, but can follow you around if you are the only person in frame. If there are other things in the room, it can still follow you around, but there's not obstacle detection right now, so it can and will just run into things. Right now, the camera is using the YOLO V3 model to detect and put boxes around people in the frame. And then we have code that takes the location of the dot as well as location of the box and gives directions on where to move so that it can follow you around.
All right, so we've sort of had two somewhat significant setbacks. The first one is that the motors that we got they're pretty cheap. They're not like the best motors because we wanted it to be more affordable. So as a result of this, they have a lot of static friction. So it takes a relatively high power to get them started moving. And once they start moving, it spins the robot pretty fast. So this caused an issue because the frame rate of the camera is pretty low. So it would get a picture. It would see oh, I have to turn, and then start turning, and then by the time it gets the next picture, it would have turned too far, and the person would be out of frame of the camera. So that was an issue we had to resolve. And then our second setback is that we had the camera working, we had the I2C working, and we had the Wi-Fi working. But when we tried to put all these three things together at the same time, it caused a lot of issues with the ESP32, where just either stuff wouldn't initialize properly or the camera capture would fail. And we still don't fully understand why this is happening. But we did find a workaround. So we'll talk about that on the next slide. So as a result of these setbacks, there's some changes to our design. So the first change is to add inertial measurement unit. So we can have a more lower level control loop that can just control the angular velocity of the robot, taking data from an MPU 6050 and then feeding that through a PID loop into the PWM outputs to the motor. And this allows the robot to have a much more controllable slow movements as opposed to the faster jerky movements that we were having without the MPU. And then a higher level PID loop will take the person location and output an angular velocity, which will feed into the nested second PID loop. And for the second issue, the workaround we have for our prototype is just using two ESP32s. So the first one will take the picture and send it to the server. And the second one will receive the data from the server and communicate with the IMU to control the motors and run the control loops. But we do hope to figure out a better solution to this. I don't really see any reason why it's impossible for all these three things to be happening at the same time. And a few ideas we have is bit banging I2C so that we don't have to use the I2C peripheral, or we can use different pins than are what is broken out on the ESP32 cam, because right now there are some pins that are being used for I2C to initialize the camera, but those pins are not broken out onto the breakout board. So we can't access them without soldering directly onto the board, which we may have to try for our next prototype.
Yeah. So learned so far. So we were not able to control the quack DAC. So we were trying to use IMU to control angular momentum control of the device that made the robot motion smoother. So this was helpful so that the robot was moving in a smoother way from left to right and right to left. And then we were trying to use OpenCV for image processing, but we came to know that it is a little difficult and we were not getting desired output. So we were trying to use YOLO V3 model for image processing, and it worked really well. Yeah. So the next thing is interviews. So we interviewed Professor Nick and Russell Joseph. So these are the questions that we asked. So they were expecting expected features that they recommended were sleep mode and auto charging. So if the toy is not in active mode, so it can go to a sleep mode, which is more energy consuming, and also sound effects, which will make a toy more interactive and more fun. So and the feedbacks were positive. So they suggested that this can be also used as a monitoring system. And then we also had other doubts like how to avoid obstacles. So we got answers like we could use IR sensors, ultrasonic sensors, lidar, and also data from the camera to avoid obstacles, and also bug algorithm like Roomba. And then battery selections, we had doubts in battery selecting whether we can use a small size battery for 6 volts. And then we got a feedback saying that it is based on the capacity that the battery can hold and the discharge current rating and output voltage, and it is possible to use a smaller battery, and it is not that dangerous. Yeah. And the next thing is and questions for the class is can you guys give any suggestions on lithium battery that we could use in this project? And can you suggest some image processing methods that can perform better than YOLO V3? And I mean, do you have any suggestions on how to reduce the latency between ESP and the server? Yeah. Thank you.
Thank you.